Well, good morning, everyone. Welcome to the C&E Sales Monthly Webinar Series. I'm Jeff Butler, the Technical Manager here at C&E. Today's webinar is titled Simple Sensor Replacement, and we'll focus on IOLink technology. Our presenter today is Brad Hart, one of the automation specialists here at C&E. Brad's been with us for almost 14 years. He holds a BSME from University of Louisville. He spent his entire career in the field of industrial automation. Just a few housekeeping items before we start. If you have questions during the webinar, please submit them using the control panel tool on the right side of your screen, and we'll address those at the end of the session. If you don't see that tool, click on the red horizontal arrow. Everyone registered for the webinar will receive a link to the recording, so if you can't take notes or are trying to feverishly keep up and take notes, you'll be able to get the recording and look at it at a later date if you'd like to. I also want to remind you to attend next month's webinar. It's going to be hosted by Kevin Young of C&E Sales. His topic will be how to use C&E Sales to quote your motion system. Just like Brad is one of our automation engineers, Kevin's one of our motion engineers and works with motion control all day, every day. We have 3 guys that do that. And we would like the opportunity when you have motion applications to sit down with you, discuss what you're trying to accomplish, and help you pick the most appropriate solution for what you're trying to do. Kevin will be covering how that typically works. That webinar will be hosted on May 3rd at 10:30, and I'll now turn today's webinar over to Brad.
Well, thank you, Jeff. Can you hear me okay?
You're coming through loud and clear.
All right, good deal. I'll go ahead and start recording the broadcast here. Okay, so I want to thank everybody for attending the webinar today that I have titled Simple Sensor Replacement. And hopefully this will give you a taste of what this new technology is and how you may be able to apply it in your applications. So, time is money, and you hear that phrase used often, and it rings true in manufacturing. Companies can measure their lost revenue to the hour, minute, and even second when they are unable to run production due to unexpected breakdowns. Unscheduled downtime happens, but are you equipped to handle every possible scenario? Likely not, but being prepared to be able to react quickly can help minimize any downtime event. Ideally, the production should run without any failures. Depending on the type of failure, it could take minutes or hours to correct for the failure, which often results in the replacement of a part. Mechanical failures could require several people to correct. Electrical failures, I believe, should only require one person to correct. Modern PLCs can be replaced by simply moving the memory card from the failed unit to a replacement unit. The same is true for modern drives and for modern HMI panels. A laptop is no longer needed in order to set an IP address or to download a program. Using the Prophynet topology technology, the coupler or interface module of a failed I/O station can simply be replaced without having to assign an IP address using a laptop. It is to your advantage and benefit to use these technologies to minimize downtime and to maximize profit. When it comes to sensors, you either measure a property such as temperature, pressure, or flow, or you can detect an object's position. Encoders can provide motor position, and RFID provides identification of a part or carrier. As sensing challenges have evolved, so has the technology. Sensors like the Banner Q4X give you the ability to teach a sensing range or a window using a push button locally on the sensor itself. This provides the ability to use one sensor for multiple sensing applications. You no longer need separate sensors for separate sensing distances. This meant you could reduce the number of spare parts in inventory. Sensor technology has improved, including the robustness of the sensor, and they last longer. However, sensors do get damaged. If a teachable sensor gets damaged, then you would have to reteach the replacement sensor. Unless you teach sensors every day, you will need to find the data sheet for that sensor and then reread the data sheet in order to teach the replacement sensor. Once the sensor has been identified as being failed, a replacement sensor has to be located and brought to the machine. The data sheet has to be found and the sensor has to be taught. It could take several minutes more to replace a teachable sensor as opposed to a dumb sensor. A simple sensor replacement was only possible for dumb sensors, but not for teachable sensors. Prophy International is the governing community that brought to industry the technology leader in serial networks with Profibus and the technology leader in Ethernet networks with Profinet. The original members included Siemens, ABB in Ingersoll, and has grown to over 1,400 members worldwide. Their leadership continued with the development of IOLink. The goal was to bring communications through the last meter cable to the sensor. For a 3-wire proximity sensor or photo eye, the sensor was already supplied with 24-volt DC power via the brown and blue wires on pins 1 and 3. The black wire provided the digital signal. It made sense if we're able to turn that pin 4 black wire from a digital signal into a communication signal. This would allow the same sensor cable to be used. The IOLink standard allows for an unshielded sensor cable to be used up to 20 meters long. IOLink is not another field bus, but truly a single point-to-point communication link. 2 milliseconds is the typical transmission time for a 16-bit process value. This opened up the capability to bring measurement sensors into IOLink. Analog sensors that would use 2-wire or 4-wire twisted pairs with a shield drain wire can now be connected using a standard 3-wire sensor cable. For devices that required more power, a 5-wire sensor cable can be used, with the white and gray wires on pins 2 and 5 providing a secondary power source. Just to let you know, as in the case here in the first diagram, port class A with IOLink on pin 4, remember pin 2, which is what the white wire would be connected to, is available to be used as a standard digital input or a digital output. So IOLink sensors are called IOLink devices. Each device requires an IOLink master port for the single point-to-point communication. Before IOLink, a digital sensor required the appropriate sourcing or syncing input module for 24-volt DC, or 120 volt AC if it was an AC sensor. An analog sensor could require either a voltage or a current analog input module, or even a thermocouple, RTD, or millivolt module. An encoder requires a counter module, while RFID requires its own RS422 interface communication module. With IOLink, the process value of all of these measurement devices and data from identification devices can now be brought into a common IOLink master module with multiple ports. The IOLink master module could reside in the local PLC rack or exist in a networked I/O station. Each IOLink device has process data that updates cyclically. Additionally, each IOLink device has additional memory areas in which you can read and write parameters. But how do you know where to access these parameters? Much like a GSD file is for Profibus and Profinet devices, and an EDS file is used for DeviceNet device, an IODD file is used for IOLink devices. IODD stands for IOLink Device Description. This is an XML file that can be imported into a port configuration tool for configuration of the parameters. Siemens uses their port configuration tool known as PCT for their IOLink masters, and Turqu uses Pactware for their IOLink masters. These parameters can also be read from and written to directly from the PLC. Siemens has their function block instruction to access these parameters, and Turqu uses add-on instructions for use in an Allen Bradley Logix 5000 based PLC. IOLink was created roughly 10 years ago, and within the last 4 to 5 years, IOLink has started to come into mainstream as more manufacturers have designed sensors with this technology. IOLink version 1.1 gave IOLink the muscle with a parameter assignment server. This provided the ability to save or backup parameters from the IOLink device to the IOLink master, and to restore parameters from the IOLink master to the IOLink device, with backup restore enabled on the IOLink master port. When an IOLink device is connected for the first time to the newly configured master port, the master will read in the parameters from the IOLink device and save it, effectively creating a backup of the device. While connected to the master port, if a parameter is changed locally on the IOLink device, not only is the parameter value saved in the device, but it is also saved with the master. Now, if the IOLink device were to fail, simply replace the failed device with a new device. The master will detect the replacement device and will write or restore parameters to the replacement device. This will occur for a new device, a device that has been set to factory default, or a device that had been in use previously. The only exception is in the event the device is powered up separately from the master and at least one parameter on the device is changed during this time. Now, when this device is used to replace a failed device, the master will not restore parameters to the device. Instead, the master will save the parameters from the device. In this case, the sensor was configured either through a port configuration tool like Pactware, or the sensor was taught a new value using the local teach without the sensor being connected to the main master. It's time for a demonstration. So I'm going to take a Turqu TBEN L5-8 IOL, which is an 8-port master. I'm going to set it up using a web server built into the master. Now we'll take a Banner Q4X. Using the local teach buttons, I'm going to set up the sensor. Now I'm going to show how the simple sensor replacement happens. All right. So it looks like my live video here is working, which is a good thing. So here's my TBEN L5-8 IOL. I'm connected over Ethernet into the back of my laptop. And I've got two Banner Q4X sensors that are IOLink. These are the 300 millimeter distance versions. And I've got one labeled BH for Brad Hart, and the other one is not labeled, so we can identify the differences. Now there is a utility called IP address tool. So if you ever use the Turqu block, when you get it from the factory, you may not know the IP address in it, but you can launch this Turqu IP address tool and do a search, and here it would find the unit. Now from here, potentially you could change the IP address based upon whether the rotary switches, which are found behind this window, are set for PGM or PGM DHCP. So you could do use a DHCP server to set the IP address. It does also have a boot P setting with the rotary switches. This one happens to have a .100 IP address, so I'm going to leave that as is. So if you type that into the URL, the IP address, then you can bring up the web server of the Turqu block. Zoom in on this a little bit. So here below on the list, we have the IOLink ports. Okay. Let's see if this is refreshed. Looks like it's working here. Make sure my cable's plugged in the back. I may have to relaunch that just for the fact that the plastic clip is broken off the end of the Ethernet cable. You always say that. There we go. Now we're back in. So you can configure the parameters of each master port by clicking on the IOLink port and going to parameters. Now, currently we are not logged into this station, but I want to show you that by default from the factory for the Turqu block, the data storage mode is set to deactivated and cleared. This is the field that Turqu calls that essentially is the backup restore parameter. Now I'm going to type in password, and now I can actually change the data storage mode. So by default it's deactivated / clear. I'm not going to change it at this time. But I want to show you that port 1 is set in this manner, and port 4 is also set in this manner. Going back to my camera, I've got my cables plugged in to port number 1. That's easy to see. And port number 4 down here as well. So I'm going to take the Q4X that's not labeled. I'm going to plug them into port 4 and get power. There we go. And this is at the factory default state. So for 300 millimeter sensor, the trigger point should be 150 millimeters, and it is. And we can see the light on the front of the sensor change state. Okay. I want to plug in the other sensor that's labeled BH. If I remember, this is also has been set to factory default for 150 millimeters. Okay, so on the front of the sensor, I'm going to teach it. I'm just going to hit the plus button here. Now it's flashing, and I can start to increase my sensing distance. I will take it up to, let's say, 170. Wait a moment, and then it would save that change. Now, as long as I am 170 millimeters or less from the surface that I'm trying to sense, it's going to trigger the output. I'm still plugged into port 4. I'm going to unplug this sensor. Take the one that's not marked, plug it in, and I should still be reading and triggering at 150 millimeter distance. And there we are. So I wanted to illustrate that and then go back and re-plug in the sensor that I had taught to 170 millimeters. Just to show you that there is no change. Okay. Now remember that this port has been programmed as data storage mode to be deactivated. In other words, it's not going to back up any parameters from any of the connected devices at all. So it has no effect, regardless of what sensor I plug in. Nothing's going to exchange, read, or overwrite parameters between the two units. Okay. Again, just to show you one more time, going to port 1, which also has the data storage mode deactivated. So again, we're looking at the BH. This should be 170. And it is. I plug the other one in, and it should still show 150. And there's the 150, okay? The other thing I want to illustrate before I make any changes to the master is using Turqu Pactware, the port configuration tool. This is the single port master that I'm going to use to connect to the sensor. So I'm going to take the one that I changed to 170 millimeters. I want to plug it in to the single port master. Okay, and then I'm going to launch Pactware. We use Pactware version 5.0, which I think is the latest. That's the one that I have. Okay, and I'm going to right mouse click over my host PC and add a device. I'm going to add the IOLink USB Master 2.0, which is this box right here. That has been added. Now I'm going to right mouse click over that master and add a device once again. This time I'm going to point to the IODD file for that banner Q4X. I'm going to use this one right here. Click on OK. Now, if I right mouse click over that device and say connect, I'm going to actually make a real-time connection, as can be seen with this green highlighted color, to the sensor itself. Now, if I double click on that, I could bring up the parameters to the right. Now, I have to click on this icon here that says read from device, essentially reading the parameters from the device and populating the sheet here in Pactware. I do that once, it'll populate the fields, and then you can see that first point being 170 millimeters. Okay. And with this utility, you could go through and you could change the value. I could say instead of 170, maybe I will make this 200. When you do that, you have to say write to device and download to the sensor. Now, if I were to move my sensor, get a little closer so you can see the display, I use my hand to help trigger. Now you can see it's now at 200 millimeters as the trigger point. So I'm going to disconnect, and really with this port configuration tool I can set up all sorts of parameters on the unit. I can even reset the sensor back to the factory setting. Okay, so now I'm reading it at 200 millimeters away. I'll unplug that. Again, I haven't done anything to the masters over here. I'm just going to plug in my sensor just to verify that it is truly reading 200 millimeters away. And it is. Okay, so I'm going to unplug the sensor. I don't have any of the two plugged in. Now I will make a change to the master for port 1 and for port 4. And all I am going to do is change the data storage mode from deactivated to activated. I need to click on submit. I'm going to verify that it took, so I'm just going to click on port 2 parameters. He's still deactivated. Port 1 parameters, it is truly set now in the master. If I go down to port 4 and click on parameters, I see that port 4 is deactivated. If I click on activated and submit, I'll click back on port 2 and then go back to port 4 just to confirm that it did take, and it did. So just by changing that one parameter in the master, effectively set up the backup restore functionality for the parameter assignment server of the master. Excuse me. Okay, so let's see this in action now, this simple sensor replacement. Okay, bring the camera back up. So what I'm going to do is I'm going to take the one that senses at 150 millimeter and plug it into port number 1. And by doing that, what happened almost instantaneously is the parameters from the IOLink device, the sensor, were backed up and saved into port 1 of the master. And we can see that our read-write distance is 150. I'll leave that connected. I'm going to take the other one that has been set up to a read-write distance of 200 millimeters. I'll plug it in. As soon as I do that and it boots up, then bam, the parameters were saved and backed up into port 4. So now, it's about tilting this, you can see that the trigger point is 200. Okay, that's at 200. This one is at 150. Okay, so now here's the situation. This sensor has failed, reading at 200 millimeters away. I want to take him off. I want to set him over to the side. Now I'm going to rob Peter to pay Paul. I'm going to take a sensor that was in use on another machine and bring it over here. That machine's not running. It's not producing anything. So I'm going to run over here and attach it to port 4 to replace the failed sensor. We know that this one was set up for 150 millimeters, but now, look at that. It's now reading at 200 millimeters as a sensing point. What happened is, as soon as I connected the unit, the master was able to determine from the newly connected IOLink device that, hey, it's time to restore the parameters back down to the device. Essentially what happens is there's a bit on the sensor, on the IOLink device, that's, I believe it's called DS upload or DS flag, one of the two. And the bit's either low or high. So the master is always checking when a device is connected the status of that bit and determines based on the status of that bit if it's going to do a backup or a restore. So this did a restore, and that's why we're reading at 200 millimeters. Okay. I want to disconnect this from port 4. and put it back on port 1. So I am paying back Paul from Peter. And now this should read at 150. And it sure is. Illustrating the simple sensor replacement, which is the whole purpose of this webinar. I didn't have to go and dig out a data sheet. I didn't have to go back and reteach, this smart sensor. Because of IOLink and the parameter assignment server, just by changing one parameter on the master port, I can replace a failed smart sensor with another one, connect the cable, and just walk away, which is huge time savings when you want to get production back up and running. So that's that particular situation. Now, this is the 50, right? I take the 200 unit, now plug it back in, we should read 200 as the target distance. And there it is. Now here's a situation which was number 4, where if the sensor was connected up to, let's say, Pactware, and the value was changed, or if it was powered up separately, let's say from a just a standard 24-volt DC power source, and you go in and I teach the sensor, holding down the value, it's set for 200 right now, and let's say I'm going to take it down to 175. And then it stores it. Now we should be triggering at 175. And sure enough, we are. By doing that, it actually flipped the status of that DS flag or DS upload bit to the opposite state. Now, if I unplug this from my 24-volt DC power supply and go and plug it back into port 4, the master is going to recognize that that bit is in the opposite state, so it will do a restore from the master to the sensor. I'm sorry, I just overstepped it. It's actually going to back up. I apologize. It's going to back up the value, the new value, from the sensor to the master. Apologize for that. So now we should see that it's going to trigger at 175, and it is. So the master backed up or saved that new value, and once it did that, then it flipped that bit, that DS flag or DS upload bit, back to the correct state. So now if I remove this at 175, take the other sensor that's reading at normally 150 and put him on to channel 4, we should also see now that this sensor is going to be sent the new parameters via a restore, and it should read 175 as a trigger point. And there it is. If I took the one that's reading 175, put it back into port 1, the master is going to restore to the device, and it should read just 150. So by doing this a couple of times, I've been able to demonstrate to you the simple sensor replacement capability using the IOLink technology. I mean, this is a big game changer, and for this reason alone would be compelling evidence for you to investigate using IOLink technology in your applications. So here's another use for IOLink. When you're doing IOLink technology, the whole notion of it, in addition to the simple sensor replacement, was for you to be able to take, an analog value, an RFID information, encoder value, it doesn't matter what the sensor type was, and bring it back to a common master module, an IOLink master, and send that back to the PLC either over a network such as Profinet or Ethernet IP or Profibus or any number of networks, even ASI, Aussie, AS interface, which is Aussie. Not only could you do that, but even if you had an IOLink master module residing in the local CPU rack, could you also do that? So here I have on the left-hand side the TBEN LX, because it could be a 4-pin powered unit or a 5-pin powered unit. 8-port master, where you could have up to 8, in this case, 8 of the Q4X sensors connected. Now, they don't all have to be Q4X. They could be a mix and match of different brand and types of sensors. On the right-hand side is the TBEN S2, 4-port IOL, a much smaller form factor, but up to 4 banner Q4X sensors can be connected. All right, but there's another way to apply this technology. And that is, what if the PLC you have that exists in your machine does not support IOLink? It cannot support IOLink because, number one, it doesn't have a way to do networking at all, and it cannot support a in-the-rack slotted module for an IOLink master. And maybe all the slots are already filled, or maybe it just cannot. There's not a IOLink master module made for that brand PLC. Well, here's a case where you can still take advantage of the simple sensor replacement for that type of application. And here's how we do it. Where before we had the sensor going directly to each port, in this case we take now the sensor connecting to one branch of a 2-to-1 splitter that's connected to the IOLink port. And then the other branch of the 2-to-1 splitter, we bring a single wire, essentially the white wire, over to a 4-to-1 splitter. So we take 4, what would be, in this case, the sensor would have to have this capability. The banner Q4Xs and some of the other banner sensors do. They have a channel 2, which is pinned to the white wire, which would be a digital output. So we could take that digital output of this banner Q4X, bring it through the 2-to-1 splitter, and just take that white wire essentially into a 4-to-1 splitter, and those get combined into a single home run cable, which would just be a 4-pin M12 sensor cable. So those 4 wires, then you could run back to your PLC enclosure and land those 4 wires onto a standard digital input module. Now bear in mind that the banner Q4X channel 2 outputs are only PMP outputs, so you need to ensure that you have the proper digital input module to accept those. So in the case of the TBEN L4, L5, the 8 IOL, you would have, if you have all 8 ports filled, you would have then 8 of the 2-to-1 splitters and 2 of the 4-to-1 splitters. For the TBEN S2-4 IOL, we could do the same thing with 4 of the sensors. Again, using 4 2-to-1 splitters and 1 4-to-1 splitter. So this is how you can use simple sensor replacement technology via IOLink for a PLC that just cannot support IOLink. So it's a great workaround, and we've got these cables that we can order from C&E. So talk to your salesperson if you have an application for something like this, and we can work to solve this application for it. So we've already got the cables that can do this. Bear in mind that there are multiple types of masters available from Turqu to do this. We've talked about the TBEN, the L5, and the S2. There's also the BL Compact. You can do an IOLink master and these form factors. The BL67 modular IP67 system, the BL20, in the cabinet with 4-port masters here. And then we have the hybrid modules. There's one for Prophynet where you can do both IOLink, standard IO, and safety IO in one module. And then we also have the one here for SIP safety for use with an Allen Bradley safety PLC. So we have the safety IO, IOLink ports, and standard IO. Those are the hybrid modules. Siemens IOLink Masters are available with the S7-1200, ET200SP, IO systems with the 4-port module, ET200S as well, ET200 Pro form factor, ET200 Eco, and through the ET200AL. Available IOLink sensors. You get the Q4X used here in the demonstration, the LE type laser displacement sensors, QS18, Easy Array, the ever popular Tower Light, the TL50, laser time of flight sensors, and even fibers. What's available to you from Turqu, proximity, ultrasonic flow and pressure, temperature, linear position, inclination, rotary. These IO hubs, which you can take a single black wire over IOLink and get up to 16 total digital points. Then you have the use of the inductive coupler for a close wireless proximity application. Looking at the Siemens IOLink devices, Siemens chose to go the route with stuff in the panel. So you can do things with compact starters, a traditional contactor with MCP. We got monitoring capability for under voltage, over voltage, current, power factor, overloads. There's even a 4 digital input, an 8 digital input, thin mounted, machine mounted IOLink masters, push buttons. Here's the RFID, the RF200 from Siemens, and there's even the ID key switch. So just want to point out to you that there is a large variety of devices that are available to you with IOLink, and please take advantage of this new technology, because you want to keep that production line running, keep downtime down to a minimum with breakdowns, and maximize your profit. That's the end part of this presentation. Jeff, are there any questions?
Thank you, Brad. Nice job. At this point, there are no questions, but the floor is open for questions using the the question box in your control panel on the right-hand side of your screen. And so we'll wait a minute or so and see if we have any questions pop in. Just as Brad is one of our automation engineers that focuses on all of our automation products, the HMIs, PLCs, IO devices, RFID, all the things that you saw today. We also have other disciplines at C&E, other specialists. We have motion control guys, we have machine safeguarding, vision, and we can, all those guys get to focus in on those disciplines all day, every day, so they get to be very good at them. And so we can bring that expertise to your factory or your if you're a machine builder, to your facility, and help you starting really at the concept stage, and help you understand what all the products are that are out there and technologies that are out there to try to help you be successful. Brad, I don't see any questions coming through, so at this point we will end the webinar. All of you who have been on the webinar today will receive a link to the recording, and we'll make sure we get that to you. And thank you for attending. Thank you, Brad.
You're welcome.